In this video, I'm going to be deriving length contraction. So length contraction is a phenomenon that Einstein figured out in the early 1900s in his special theory of relativity. So let me just give you the gist of it, the intuition of the length contraction first, then I'll derive it. So as you're speeding, some speed, some fraction of the speed of light, length contracts. You would contract, and space around you contracts in a direction that you're moving. So let's say you're moving forward, space around you will contract in front of you and behind you, and it will contract toward you. And everything in space, a meter stick in space, somewhere, some distance from you, is going to be the same meter stick somewhere else, and it's going to be smaller. So that's length contraction. So at light speed, if you're moving at the speed of light, light contracts instantly. And light does not travel distances. There is no distance for light to travel because it's traveling at light speed. And there's also no time for light to experience because time dilates instantly at light speed. So light gets from place to place instantly. And length contraction is derived from the two postulates of relativity that all inertial reference systems, the laws of physics are the same for all inertial reference systems, and the speed of light is the same no matter the speed of the observer or the speed of the source of the light. And let's get started. So let's say you're on Earth and you want your friend is on a rocket ship headed to Alpha Centauri, the Alpha Centauri star system, which is about 4.3 light years away. And from your point of view, the time that it takes, or the distance that the rocket ship must travel, is going to be called the proper length. And the time that your friend travels from your point of view is delta t. Now, from your friend's point of view, remember the time is dilated, so it's going to be the proper time. And the length contracts, so it's going to be L. Now, now that means that the velocity of your rocket ship, of your friend in the rocket ship from your point of view, is going to be v equals proper length divided by proper time. I mean, not proper time, just delta t. And from your friend's point of view, it's going to be L divided by the proper time. How is that so? That's because, let's say, the time gets dilated by a factor of gamma. It gets reduced by a factor of gamma. L also gets reduced by a factor of gamma. So, given that L gets reduced by a factor of gamma, or in other words, let's say the proper length is 4.3 light years, and let's say the delta t is 4.3 years. The length, depending on the speed, might be, I don't know, 2 light years. And that means that the time, delta t, would be 2 years. And those ratios stay the same. So the velocity is the same. So let me make some room here. If you recall, the proper time is equal to delta t times gamma. So with the equation that L is equal to L divided by the proper time is equal to the proper length divided by delta T. If we rearrange that equation, we'll get delta T, the proper time divided by delta T is equal to L divided by the proper length. So rearranging this equation, we get the proper time divided by delta T is equal to gamma. So we have this and this are the same. So if this is this and this is this, we can put this right here. Erase out them circles. Oh, backspace too much. So let's do that. Let me make some room. So we have that the length divided by the proper length is equal to gamma. And what we have is that the proper length is equal to regular length divided by gamma. And this is the length contraction equation. And that's it for this video.